So you learned how to convert degrees to radians, and if you look at the directions at the top of your page and you're going to take notes in your packet, it says to convert each of the following angles into radians. So we're simply going to take that 30 and we're going to multiply it by pi over 180. Remember that 30 is like 30 over 1, and when we multiply fractions, we multiply numerators, so that would be 30 pi over 180. And then when we reduce that, that's pi over 6. So 30 degrees in radian form is pi over 6. All right, let's go to part B. Again, make sure you're taking notes in your packet. So now we have 45 degrees. So we're going to do the same thing. We're going to multiply that by pi over 180, this over 1. And when we multiply fractions, we multiply numerators with numerators. So that gives us 45 pi. And denominators with denominators, that gives us 180. And remember, in your calculator, you can always do 45 divided by 180 and get your answer as a decimal and do math fraction. And that will give you 1/4, which then means that would be pi over 4. All right, last one. So now we have 60 degrees. We're going to multiply that by pi over 180. Same as the others. So we're going to get 60 pi over 180. Reduce 60 over 180, whether that be in your head or in your calculator, and that is going to be pi over 3. So now the reason why we did part A and converted 30 degrees, 45 degrees, and 60 degrees into radians is if you look halfway down the page, you'll see a chart. And it says the special angles chart at the top. 30, 45, and 60 are considered what we call special angles. So if you notice your chart is already filled out, I'm filling mine out and I want to talk with you about it at the same time. So when you do this chart, if you ever need to know what the sine of any or the cosine or the tangent of any of these special angles are, you may find that this chart would be very helpful for you to write down at the top of your page, at the top of a test, anything like that. So when you do write it yourself, you look here, I have like a 4x4 box here. So I go in numerical order from least to greatest. The special angles are 30, 45, and 60. So 30 is the smallest, 45 then obviously is the next, and 60 is the largest. So when you put them in these boxes, just make sure that you go in order from least to greatest. Now remember, look at part A, and 30 degrees we also know is equivalent to pi over 6. 45 degrees we know is equivalent to pi over 4. We're going to use these a lot, so it's very helpful if you kind of have them memorized. And 60, its equivalent is pi over 3. Now, going down this left-hand column, obviously your chart is already filled out, but we go in SOHCAHTOA order. Remember, SOHCAHTOA, SOHCAHTOA. So we do sine, right? That's our SO. Then we do CA, which is cosine. Then we do TOA, which is tangent. So down this left-hand side here, we do SOHCAHTOA, and across the top, we do numerical order from least to greatest. All right, so there's a little trick to memorizing what the sine of, let's say, there's a little trick, as I was saying. So like if I wanted the sine of 30, or I wanted the sine of 45, or the sine of 60, we have a little trick to doing this, and I think that you'll find this pretty helpful. So basically what you do is everything in here is pretty much going to be a fraction. So when you write this, just maybe watch it first because I'm going to write the numerators. So what you do is you go 1, 2, 3. Then the next row, you go 3, 2, 1. Pretty easy, right? 1, 2, 3, 3, 2, 1. Then these are all numerators to fractions. So we're going to make all of these guys fractions. And every single one of these denominators is going to be a 2. Okay? Every single fraction gets a denominator of 2. Then all of the numerators are going to get radicals. The only thing is that I'm going to point out is that we really don't need to have like the square root of 1, because I know that the square root of 1 is 1. So you can put a square root here if you want, but I tend not to because I don't think it's really necessary. But if you put it, it's not wrong. So I'm going to put a square root there, square root there, square root there, and square root there. Okay, so let's just kind of go back and let's just check this again. So we go 1, 2, 3, 3, 2, 1. Notice all of our denominators are 2's and all the numerators get radicals. The only reason why my 1's don't have radicals is because the square root of 1 is 1. But again, if you put it, it's totally fine. All right, so then we have this bottom row here, and this one's a little bit, set apart from the rest of this chart. It's not as easy. So what I do is I always put a big old 1 right there in the middle. So the tangent of 45 degrees is 1. Now, if you look then here and here, I have 2 blanks, right? So basically what those get is they both get radical 3's. However, the angle that has a 3 in it, see, we're looking at 30 versus 60. The angle that has a 3 in it, that value down here gets an extra 3, like that. Okay? So I'm going to try to go through that one more time. I know it's repetitive, but it'll make it a little bit easier. So it goes 1, 2, 3, 3, 2, 1. All the denominators get 2's. All the numerators get radicals, except for the 1's because the square root of 1 is just 1. For this bottom row here, a big old 1 in the middle. These 2 guys both get a radical 3. And then look at those 2 angles that they go with. The one with the 3 gets an extra 3 right there in the denominator. So now, if I asked you, oh, okay, what's the cosine of 45? You could say, here's cosine, here's 45. Let's follow that out. The cosine of 45 degrees is radical 2 over 2. All right, what's the sine of 60 degrees? Sine, follow it out to 60 degrees. The sine of 60 degrees is radical 3 over 2. And these are values that you're going to use a lot. So that's why we're having you write down this chart in your notes, because we will be referring to it quite a bit. All right, so the last thing that I'm going to talk about is, you'll see this at the bottom of the page, and you see this this thing here. You've got an A in the first quadrant, you have an S in the second quadrant, a T, then a C. We have a little mnemonic device which helps us remember what this all stands for, and it's called All Students Take Calculus. Ha ha ha. Okay, so all students take calculus. So basically this is what this means. In the first quadrant, all of your trig functions are going to be positive. So that would be sine, cosine, and tangent. All these guys are going to be positive. Okay, A for all. Now take a guess. What do you think is going to be positive in that quadrant? Begins with an S. So if you guessed it, you are right. Sine will be positive in the second quadrant. Okay, which means if sine is positive in the second quadrant, then cosine and tangent, those guys are going to be negative. So maybe you're not quite following what in the heck I'm even talking about. Pick an angle that's in the second quadrant, like, I don't know, 100 degrees or 120 degrees, anything. Anything, remember, that's bigger than 90 and less than 180. Pick any angle. Take your calculator and hit sine of whatever that angle is. Let's say like the sine of 100 degrees. Then do the cosine of 100 degrees. Then do the tangent of 100 degrees. And you'll see that your answers For sine will be positive, but your answers for cosine and tangent, you'll get negative values. So that's what I'm referring to. Okay, let's look at the next one. So then obviously, what do you think is going to happen here? What do you think is going to be positive there, right? It begins with a T. So then tangent in the third quadrant is positive. Oops, let's make that look like a positive sign, which means every other trig function, which would be cosine and sine, will not be. They'll be negative. Okay, so the only thing that's going to be positive in the third quadrant is tangent, just like the only thing that's positive in the second quadrant is sine. Now you can do the same thing. Pick an angle in the third quadrant, so something that's bigger than 180 and less than 270. Okay, anything. And take the sine of that angle, the cosine of that angle, and the tangent of that angle. The only answer that you should get that's positive is the tangent. Okay? All right, so I'm sure that you can figure this one out now at this point. So here in the fourth quadrant, cosine will be positive, which then means that sine and tangent will both be negative in that quadrant. All right, so then basically all this is helping us find and determine, and we'll use it more in examples coming up, so it'll make a little bit more sense, is what trig functions are positive in which quadrants. So just to kind of review, everything in the first quadrant is positive. So you take any angle that's bigger than 0 degrees and less than 90. If you take its sine, its cosine, or its tangent, you'll get a positive answer. In the second quadrant, a second quadrant angle, the only thing that will turn out to be positive is the sine. Okay, everything else is going to be negative. Third quadrant, the only thing that's positive is tangent. Fourth quadrant, the only thing that's positive is cosine. All right? Please make sure that you took notes in your packet for all of this.